Today we're going over lesson 10.6, finding segment length in circles. And it's exactly what the title says. There's going to be formulas that deal with segment to inside and outside circles. Starting off, segments of chords theorem. Basically, the rule is if two chords intersect, no matter where they intersect inside the circle, the two parts of one chord, so AE times EB, when multiplied together will equal the two parts of the other chord, CE times ED. Or in this case, they like to do E, so EA times EB equals EC times ED. We'll prove this one, and again, with these auxiliary lines, very important, right? They added AC and DB. Once you see that, you kind of see the triangles, so pause the video and look for a plan to prove this in about 5 steps. So how my plan to prove would work would say that I would like to look and see that these two angles here have the same arc, and these two angles here also have the same intercepting arc. So we can say these angles congruent, therefore angle, triangles aren't congruent, but they're similar, right? Notice we're multiplying, and so in order to get that multiplying, we're going to need some sort of proportional sides. So working this into the proof here, starting off, given chords AB and CD intersect is our step 1 given, and same idea, right? Our first steps are angle A and D are congruent, angle C and B are congruent, and that is because they both have the same intercepting arc. Like A and D both have CB as its arc, and C and B angles both have AD as its intercepting arc. Angles with the same intercepted arc are congruent is the reason. Moving on, once we have that, we've got angle, triangles are similar. So triangle ACE, ACE, similar to triangle DBE, by angle. And then how are we getting from here, right? We don't have equal pieces, we're going to have a proportion. We're going to say EA to EC, these two sides of this triangle are going to be similar to ED over EB. Right, EA over ED, sorry, I guess I did the short leg to short leg, over equals EC to EB, long leg to long leg. Right, so triangle 1 to triangle 2, if we label this 1 and 2. And that is definition of similar triangles, and then we cross multiply. Or multiplication property of equality, multiplying both sides by the denominator, EB, ED, to get EA times EB, ED would cancel. If we multiply this side by EB, ED would cancel here, and ED would shift to the top, just like cross multiplying. So multiplication, property of equality. Moving on, we've got solve for KJ and ML. Now, quite a few steps here because I've got sides of x plus 2, x plus 1 for chord ML, right? X plus 2 is this piece, x plus 1 is this piece, and then piece x and x plus 4 for KJ. So how this works is it's going to be x plus 2 times x plus 1 equals x times x plus 4. And then we're going to multiply these out. And this side we would FOIL x squared, x, 1x, 2x, times 2, and then we're going to have common terms here. This side was easier to multiply out, so I just did one step there. X times x squared, x times 4, 4x equals x squared plus 3x plus 2. Now to solve, subtract x squared from both sides, subtract 3x from both sides to get x is 2. Now not our answer, we got to look. Solve for KJ and ML. So now we're plugging it in. This chord is how long, right? So plugging it in, 2 plus 2 plus 4, right? We're not multiplying now, we're just finding out how long it is. So 2 plus 2 plus 4, because we plugged in 2 for the x's to get KJ is 8. ML is x plus 2 plus x plus 1, so 2 plus 2 plus 2 plus 1, 2, 4, 6. We're going to get 7. ML is 7. Moving on. Now, the next form, we've got, as a reminder, we've got secant and a tangent, and they're going to have their own rules for dealing with a circle. Now, notice they're saying secant, we can talk about the outside part or external versus the whole. and we will use that for the formula. So segments of a secant theorem, right? So in this case, we've got EB, which is a secant, ED is a secant. The formula is going to be EA times EB. Okay, so look at that again. EA outside times EB is the whole. So outside times whole equals outside EC times the whole, ED. So outside times whole equals outside times whole is our secant rule. Okay. So, getting with problems. The common mistake here is people take the last rule and apply it. Oh, 5 times x equals 6 times 9. No, not working that way, right? It's outside 5 times the whole, 5 plus x, equals 6 times 6 plus 9. So that's our setup. 5 times 5 plus x equals 6 times 6 plus 9, right? You have to add both pieces together. And we're going to get 5 times 5 is 25, 5 times x is 5x. This is 15, so 6 15s is 90. Subtract 25 from each side, and we get 65 is 5x, and x is 13. If you plug it back in, 5 times 18 equals 6 times 15. 5 times 18, both those would equal 90. Next one, x times 3. Now this is the inside pieces. X times 3 equals 6 times 4. Just divide both sides by 3. 3 goes into 6 2 times, so 4 times 2 would be 8. 3 times 8 is 6 times 4, both equal 24. Moving on to the next. This would be one I'd like you to try on your own, so pause the video, try this on your own. It will take a bit of time. So continuing, this is one where it's secant. 3 times x plus 2 plus 3, right? We have to add them all together. So that'd be 3 times x plus 5, because 3 plus 2 is 5, and that is the whole length. Down here it'd be x plus 1 times x plus 1 times x, plus x minus 1. Oof, lots of variables there. So here's our setup. 3 times 3 plus x plus 2, that's before I simplified, and x plus 1 times x plus 1 plus x minus 1. Now realize the plus 1 minus 1 will cancel, and this is really just this whole parentheses is just 2x. So 2x times that is not going to be too bad. 3 times x plus 5 is going to be 3x. 3 times 5 is 15. This side, x plus 1 times 2x is 2x squared plus 2x. We got a quadratic. We got x squared on one side. We're going to have to factor. So solving by factoring, what's that look like? We got to subtract 3x and 15 from both sides. I don't know where my minus 15 went over here, but we'll just add it. And then over here we'll have 0 equals 2x squared. So 2x minus 3 is minus 1x minus 15. And then this is where factoring comes in. You do 2 times minus 15 is the top number, and the bottom number is how many x we have. Numbers that add to equal negative 1 multiply to equal negative 30. I got negative 6 times positive 5. And so negative 6 times 5. But we need to bring the 2 back in. So what happens with the 2 for the slide divide bottoms up type method is we divide both pieces by 2. One of them turns out nice. Negative 6 divided by 2 is negative 3. So x minus 3 is one of our parentheses. The other one looks like x plus 5 half. It doesn't look nice. We don't like the fraction, so we're going to move and bring the bottom up of that 2. So the 2 is going to slip to in front of the x. Basically, we multiplied the whole thing by 2 is what happened there to get 2x plus 5. But we had a 2 to start with, so that's what we're kind of do. We have to bring that 2 back. And then solving by set each piece equal to 0. X minus 3 is 0, plus 3 to both sides. X is 3. 2x plus 5 is 0, minus 5 to both sides, and divide by 2. X is minus 5 half, which is minus 2.5. One of these numbers don't work. Doesn't work. Sorry, one of the numbers doesn't work. And you got to look at it. Can we have a negative number here, right? If we plug in negative 2.5, negative 2.5 plus 2 is negative half. We can't do that math, right? You can't have a segment of a negative length. So right there, this one doesn't work, right? Negative segment length, so our answer is right here. We'll circle it with an actual circle here. X is 3. Right, so x equals 3 is the lone answer of that problem, because this one, when plugged in, gave us a negative. If you want to check it out, 3 plus 2 works, 3 plus 1, 3 minus 1. All those gave me a positive number. 4 and 2, so that would be 4 times 6 equals 3 times 8, and those are both 24. Last one is, if we have tangent and a secant, tangent is just going to be itself squared. So EA times EA, whole times whole, right, equals outside times whole. Outside times whole is how secants are going to work. Tangents are always itself squared. So we're just piecing them together, right? Tangent squared equals outside times whole for my secant. So in this case, x times x squared equals 1 times 1 plus 3. So x squared equals 1 times 1 plus 3. This is 4. So x squared is 1 times 4, or 4. What times itself equals 4? We get 2 and minus 2. Minus can't work, so we just take the plus. X is 2. And this is just a reminder that once in a while you may get a negative answer that will work. In this case, it didn't work. Okay. Next one, 5 times 5 plus x equals 7 squared. So this one we're probably not going to get a nice number because 5 doesn't really go into 7, anything that has 7 squared, but we'll try it out. 5 times 5, 25, plus 5 times x is 49. Subtract 25 from each side, and I get 5x is 24, and I get 24/5, or 4.8. Couple more, right? This one's again the inside one. This one's a secant, and plugging them in. X times 18 is 9 times 16. Divide by 18 on both sides. 9 and 18 cancel. 9 goes into 18 twice. 16 divided by 2 is 8. Or you can just plug it into your calculator, right? Either one works. Down here, 18 times 18 plus 12 equals x times x plus 29. And this is another factoring one, right? I only see one set of x, and it's going to give us x squared. So in simplifying, this was 40. 18 times 4 is 72 with a 0 equals x squared plus 29x, right? Distributing. And so we're going to bring the 720 over by subtraction. And now numbers that multiply to equal negative 720 add to equal 29. A little bit harder. The numbers are actually 45 and minus 16. So we get x plus 45, x minus 16. And we set each piece equal to 0. That's what that's reminding us. So x is minus 45 or 16. We can't be negative. So again, trying to cross off that negative answer. X is 16. If you plug it back in, it'll work. 16 times 16 plus 29 equals 18 times 18 plus 22. And that wraps up today's